my name is Craig and welcome to Peri Solutions. So today we're going to talk about how we simplify algebraic fractions. But before we start, please, if you're new to my channel, make sure you subscribe and hit the notification bell so that you don't miss out on any new videos. So I'm going to start off by looking at these three examples that I have written in black. Right. So to start off with number one, we'd like to see how we just simplify 32 over 56 the normal way. So we know 32 is 8 times 4, then 56 is 8 times 7. So we know that 8 and that 8 will cancel, such that the final answer will be 4 over 7. Right? So this exact same way that we simplify, this way that we simplify just the normal numbers, is the way that we will simplify algebraic fractions. But now the difference is that we'll be just having unknowns and as well actual figures like the 7, 5, 5, 3, 2. Right. So now let's move on to look at number B. So example B, it says 3a over 5a squared. So we know 3a is 3 times a. Then over 5a squared. 5a squared being 5 times a times a. So you know 1a and that a will cancel each other, such that the final answer that we want to be 3 over 5a. Right. And then now to look at example C, it says 3y plus y squared over 6y. So in the numerator, we know we can factor out y. Y into 3y, we get a 3, plus y into y squared, we get a y. Then over 6y, so y in the denominator will cancel with the y in the numerator, such that the final answer that we want would be 3 plus y over 6. So this is the final result that we get. So now I'd like to look at these 10 questions that require us to simplify the algebraic fractions. So allow me to erase this part in black. Okay, so now let's start. So starting off with number one, it says 7a squared b over 35ab squared. We can rewrite this as 7a squared b being 7 times a times b over 35 being 7 times 5 times a times b, like that. So we know that 7 and that 7 will cancel out, and 1a, then 1b and 1b, right? Such that the final answer that we want would be a over 5 times b, which is 5b. So this is for number one. Then for number two says 5x plus 2x squared over 3x. So with number two, we know that in the numerator, we can see that we can factor out x. So if we factor out x in the numerator, we're saying x into 5x, we get a 5, plus x into 2x squared, we get a 2x. Then this result will be over 3x. Right. And then we can see that this x and that x can cancel. Then we've got 5 plus 2x over 3 is the final result. Like that. So that's for number two. Then for number three, we've got 3x over 4x minus x squared. So now in the denominator, this is whereby we can factor out the x. Right, so we're saying 3x over x. Right, we're factoring out x in the denominator. X into 4x, we get a 4. Then minus x into x squared, we get an x. Then we can see that this x and that x can cancel, such that the final answer would be 3 over 4 minus x. This is what we get. And then now, let's look at number 4. Number 4 says 5x plus 10y over 15xy. So in the numerator, we know we can factor out 5, just 5. Because already the variables that we have, we've got an x separately, then a y separately. So we can only factor out the constant 5. So factoring out 5 in the numerator, 5 into 5x, we get an x, plus 5 into 10y, we get 2y. Then that result would be over 15 xy. 15 being 5 times 3. So 5 times 3 times xy. So 5 and 5 will cancel. And then you get x plus 2y over the denominator being 3xy now. So over 3xy. Like that. So that's what you get for number 4. Then moving on to number 5. We've got x squared plus 2x over x squared plus 3x. So in both the numerator and the denominator, we can factor out x. So in the numerator, factoring out x into x squared, we get an x, plus x into 2x, we get a 2. Then over, in the denominator, factoring out x into x squared, we get an x, plus x into 3x, we get a 3. So we see that x and x will cancel. Then the final answer will be x plus 2 over x plus 3. This is the answer that we get. Then for number 6, we've got x squared minus 3x over x squared minus 2x minus 3. So in the numerator, we know we can factor out x, right? Such that we've got x minus 3. Then over in the denominator. Now this denominator is a quadratic expression, and it talks about how we factorize quadratic expressions. So we shall multiply the first term and the last term to get minus 3x squared, and we shall look for factors that when you multiply them they give us minus 3x squared, and when we add them they give us the middle term, which is minus 2x. So we shall have two brackets here. I'm going to extend that, x then x. So these two factors that we want, right, when we multiply them, they give us minus 3. And when we add them, they give us minus 2. So this is going to be minus 3 and plus 1. Right. But what do we see from that? We see that x minus 3 is common in both the numerator and the denominator. So they cancel out, and the answer will be x over x plus 1. That will be the final answer. Now let's move on to number 7, right? Now with number 7, it's the same application, right? So 3x squared minus 6x over x squared plus 3x minus 10. In the numerator, we can factor out 3x. Then 3x into 3x squared, we get an x, minus 3x into 6x, we get a 2. Then over x squared plus 3x minus 10. Multiplying the first term and the last term, we get minus 10x squared. Then we shall look for factors that when you multiply them, they give us minus 10x squared, and when we add them, they give us the middle term being 3x. So we shall put an x there and an x there. So these two factors that when you multiply them, they give us minus 10, and when we add them, they give us a 3. It's going to be plus 5 and minus 2. So we can clearly see that x minus 2 is common in both the numerator and the denominator. So x minus 2 we cancel, and we remain with 3x over x plus 5. So this is the final result that we get. Now moving on to number 8, right? X squared plus x minus 6 over x squared plus 2x minus 3. We shall factorize both the numerator and the denominator. Then we see what will be common from there. So factorizing x squared plus x minus 6, right? We shall have two brackets here, right? Then we've got our x there and our x there. So we shall look for two factors that when we multiply them, they give us minus 6, right? Being the result of multiplying the first term and the last term. And when we add them, they give us the middle term, which is x. And in this case, this is just 1. So we want two factors that when we multiply, they give us minus 6. When we add them, they give us a 1. So this is going to be plus 3 and minus 2, right? Then over x squared plus 2x minus 3, two factors as well that when we multiply them, they give us minus 3x squared, and when we add them, they give us 2x, right? So we shall have two brackets as well here, then x there, x there. So these two factors, multiplying them, giving us minus 3, then adding them, giving us plus 2. This is going to be plus 3, then minus 1. Right. So we see x plus 3 is common in both the numerator and the denominator. So we can further simplify this to get x minus 2 over x minus 1 is the final result. Then moving on to number 9. Number 9, we've got 12x squared minus 20x over 4x squared. So in the numerator, we know we can factor out 3x. Oh, sorry, we can factor out 4x actually. So we can factor out 4x, right? Such that 4x into 12x squared, we get 3x, then minus 4x into 20x, we get a 5, right? And then this would be over, right, 4x squared, which is just 4 times x, right? Such that this x and that x will cancel, that 4 and that 4 will cancel. Then the final answer that we want would be the final answer that we want, allow me to erase this. Final answer that we want would be 3x minus 5 over x. So this would be the final answer that we get. Now moving on to number 10. Number 10, factorizing the denominator, we can factor out 3x in the numerator. So in the numerator, factoring out 3x into 3x squared, you get an x, then plus 3x into 15x, you get a 5. Then over x squared minus 25. This is difference of two squares. So with difference of two squares, you know that we'll be having x minus 5 times x plus 5. Then we see that x plus 5 is common in both the numerator and the denominator. So we cancel those out, such that the final answer will be 3x over x minus 5. Okay, so this was just simply looking at how we simplify algebraic fractions. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.